Hi, welcome. It's good to see so many of you here, and I'm surprised by the number of people I actually know. Thanks for joining my session. My name is Berry Langerak. I'm the Chief Technology Officer at Tilla, and I'm here to talk about the evolution of deployments and how they have evolved over the last decades. So we're going to go on a ride from FTP uploads to sophisticated GitHubs and serverless strategies and everything in between, and how it influenced us as developers. So let's go. First of all, I would like to show one of my LinkedIn recommendations that I'm very proud of, and also I think it's a very questionable thing to be proud of. Mike van Riel, he's in the audience right there. He once gave me a recommendation because my efforts saved the release more than once. For those of you who don't know, that means that I've been working a lot of nights. Let me take you back to a moment that I think many of us have either lived or narrowly escaped. It's Friday. It's 1 before 5, so you're waiting for the weekend to start. And the senior dev says, hey, just one more push. I got a really small bug fix, right? It's no biggie. It'll be fine. So you roll your eyes, as you do, and you say, sure, all right, let's do it. And it was the beginning of 2000s. So what you do is you change the code, you FTP it to the server, and everything becomes white. The white screen of death. So you figure, I want to see the logs, I want to read them, but there aren't any. The backups was a backup directory, so we haven't got much in the way of backups. And the next 3 hours are spent frantically trying to figure out what went wrong. And eventually you find out that the only correct file, or the only correct version of the file, was on Sarah's desktop. That was deployment in the 90s and the early 2000s. And sadly, I think in some places, it still is. But things have changed a lot. And today we're going to walk through how we got from that white screen to multiple deployments every day. Zero downtime, push of a button, just works. I'm going to start with the first era, the late 90s, or as I like to call it, manual mayhem. This is the time that I think a lot of you, if I were to judge your age, started. And I think you all know, it wasn't to every individual, just generalizing there. I think you all know that we had to FTP or SSH to a server and do live edits with Vim. And production servers were sacred machines, right? They were named and they were loved and they were feared. Most of all, and that was an era where there was a lot of downsides. So there was no version control, there was no rollback safety nets. Production edits were just done live, so if there was anything wrong, the customer would see it. There was a lot of configuration drifts between servers because they were provisioned and installed manually. There was a high likelihood of human errors, but I would say this for this era, it was a very good thing that you could still get away with an under construction image. I don't think it will work now. What we learned in that era is that manual work doesn't scale, and that it's very prone to failure. Deployments should not be artisanal. You shouldn't be proud that you're very good at deployments manually. You should be proud that you don't do them anymore. The need for automation and repeatability has become clear in the late 90s, early 2000s. And I think this was the early seed for infrastructure as code and ultimately version control, obviously. So as applications and teams grew, manual processes broke down. those manual processes that we were just talking about, they stop working, they stop functioning. Or you might say that they didn't even function to begin with. That's fine. In the early 2000s, we started off with bash scripts. And we started using them to automate the repetitive, boring stuff of, for example, deployments. We also started automating the provisioning of servers using tools like Chef and Puppet. Teams were beginning to standardize their environment as much as possible. It really was an era of taming the chaos that we had from the 90s. But the tools were still fragile, and a lot of errors still happened, and it required a lot of logic. The quote that you just saw from Mike was actually in this era, because we were doing shell scripts to deploy our stuff, but there were too many things going wrong, and whenever the shell script broke down, we didn't have a way to automatically fix it, so we had to do it manually. Anyway, I enjoyed the pizzas. That's something to say, at least. What we've learned during this era is that it's really good to automate the boring and risky stuff, reduce human errors. That consistency is very important, and repeatability is very important. And it set the stage ultimately for CI and CD. I hope most of you know what that abbreviation stands for. It also taught us to stop treating servers like pets and start to think of them like cattle. As in, if a server goes down, you can send it off to the server farm in the clouds. Wait, that doesn't work. Fine. You can spin up a new machine, provision it, and you can continue as you were doing previously. And after the 2000s, early 2010s, I guess, I haven't really checked the dates. This is all from my personal recollection. We got the rise of DevOps, which sounds like a title for Star Wars. The DevOps movement started breaking down the silos between development and operations. Before this, whenever I wanted to have a change implemented on a production server, I would either have to ask a colleague from another team who was doing infrastructure to make a change. For example, if I needed a new pickle package or whatever. Or worse, I had to call an external company who was responsible for the managed servers. And many of those managed service providers still exist. People started realizing that if you want to go fast, however, you need to sit together. So that's why we merged developer people and operations people, and you got DevOps. And that kicked off a lot of good things. So CI/CD became popular. Infrastructure as code became popular. And with that, we unlocked the capacity to deploy much faster and with less of a hassle, which also means that it's possible to deploy microservices, for example. I think that if we wouldn't have had DevOps, we wouldn't have had microservices because the deployments would simply be too hard. So what you see is that with the advent of DevOps, we're getting more and more and more speed in deployments. And that's a fantastic thing. At the same time, it introduces a lot of complexity too. Infrastructure as code, so Terraform, CloudFormation, stuff like that, was introduced. But the more moving parts you get, the harder it is to debug if something goes wrong. Another downside of this era specifically is that it's very expensive. Operations people used to be their dedicated team, and they were doing their dedicated work, and you could overbook them, right? So they would not be doing one project; they would be doing many projects, and they would get a ticket, and they would handle that ticket and send it back in 5 working days or less. Now, all of a sudden, you got one ops doing one project, which obviously is an expensive way of working. What we learned during this era is that culture is very important. Because DevOps, as you probably heard 1,000 times by now, it's not a technology. It's a mindset. DevOps isn't Jenkins. DevOps is a culture. It's a cultural adjustment. And I think that's what we learned. I think we learned that working together with the infrastructure is very important if you want to go fast. But we didn't stop there, luckily. I think many more good things have happened since then. Sorry. So after this, we came to the era of containers and orchestration. And this is one of my favorite eras, to be honest, because I love containers. Containers make it possible to develop something locally in a Docker container. And you can then push that container, including all of its state, to your testing environment, where you run your automated tests, to a staging environment for previews and reviews from whoever your shareholders are, stakeholders, sorry. And then, if all goes well, you can take that same Docker container image or container image, and you can push it to production. And that's not a small feat. We take it as a given, but you should realize that it works on my machine is now a joke, where 20 years ago, it was reality. That is a pivotal moment in how we do deployments and software development as a whole. So containers, awesome stuff, but you need to run them somewhere. So we quickly figured out, as an industry, that if you want to run them somewhere, you need a machine that determines where to run which container. An orchestrator, pretty much. And that saw the rise of Kubernetes, which is I think one of the most influential tools that we've seen in IT for a long while. And it's fantastic. It can do everything. And I do mean everything. You can run databases on it. Maybe you shouldn't, but maybe you should. You can. I've seen people running virtual machines on Kubernetes. It's insane. It can do everything under the sun. And it's amazing. But there's also a downside. It can do everything under the sun. Which means that you have to figure out what you want. If you take a coin and you look at one side and it says flexibility, and you turn the coin around, it says complexity. Because flexibility and complexity, they are related to each other. They're actually the same beast. And Kubernetes is incredibly powerful, but it's very complex and very overwhelming. I've dabbled with Kubernetes quite a lot, I would say. I know that some of you have, and I think it's a fantastic tool. But what we do see is that we're getting something that I never thought to know what it means back in the 2000s. But we're getting YAML fatigue. Oh, not a YAML file, man! Really? So that combined with the steep learning curve, that slows down adoption, and it does mean that you need very specific expertise to run your containers in a production environment that doesn't break whenever you try to do anything significant. The interesting thing is that we didn't shift away from DevOps. This is just an evolution of DevOps, really. Because where DevOps from the previous era was about spinning up virtual machines and configuring them automatically with Chef and Puppet and Ansible and Ansible Tower and whatnot. Now, people started working on Kubernetes and calling themselves platform operations. But there's still a very strong divide between developers on the one hand and the infrastructure people on the other hand. Regardless, we've learned a lot. We've learned that orchestration requires standardization, and a lot of really great standards have appeared from this era. And there's a lot of structure that has been introduced in this era. And the concept of immutable infrastructure has been introduced in this era, and self-healing systems. And that's big, because immutable infrastructure means that you can replace your infrastructure, including your software, in one go. So gone are the days that you had to call someone to install a specific PHP library or requirement. You can just package it yourself and push it there, and it works. That's immutable infrastructure, and it's great. So now we are here. I think, anyway. I think that we're currently in the era of serverless and progressive delivery. And deployments have become more abstract and event-driven. And we're shifting away from traditional infrastructure entirely. And I think that's fantastic. Because if you shift away from infrastructure, you shift away from complexity. And that's the thing that you want, because developers should be focusing on software, and you need tools to deploy that software as quickly as you can, but without running any risk. But with new power comes new challenges. So one of the things that you get is visibility. Sure, deployments are running. We're doing, how many are we doing a day? Yep.
I think about 50.
About 50, yeah. He doesn't even know. And that says something. So when it comes to visibility over your deployment, we used to do a release, and it was hours and hours and hours of work, and now we're doing 50 a day, and we're not even noticing anymore. That is good, but it's also something to be very cautious of. We've got the trust component, which is very interesting. I'll talk about that a little bit more later. And complexity, because complexity isn't gone, it just resurfaces in a new form. It's always choose the problem you want to have, right? I think in this day and age, and to be honest, it has been going on for a while. We've also learned that a deployment is not a release. When we were doing releases after every sprint, so we worked for 2 weeks. We didn't make the sprint, but anyway, we need to release it anyway. We would spend a few hours doing the release. And the interesting thing is that, for me at least, there was a one-on-one relation between a deployment and a release. And we don't have that anymore. And we don't have that because of feature flags. And feature flags are the greatest thing since sliced bread. every time a developer starts with Tilla, I very strongly try to influence them into thinking that feature flags are the greatest thing ever. And they are. They do have downsides, but they are. Because if you introduce feature flags to your code base, that means you can deploy 50 times a day without releasing anything. And you can release something without doing deployment. And that's a fantastic tool to have, because it also allows you to release to just a small number of people. So say 10%. See how it works. You can also release it to people you like. So beta testers and all that. And I think that's a great tool. And if you're not using it, you should probably consider looking into it. That, in turn, also gives you the opportunity to look at trunk-based development. Whereas we used to have this idea that every feature should be a branch. If you have feature flags, every feature can be in the main branch because you're hiding it not through a branch in your version control. You're hiding it through a feature flag. And that's just amazing. But we do have a few challenges nowadays too. So I already mentioned the trust part. And the trust part, when I'm talking about serverless, is if a developer builds a function, a serverless function, and you put it somewhere, you trust other people to have done their work properly. If you, as a developer, build a container and you deploy it to production, people trust that you built a container that is safe. So security used to be something that was in the hand of infrastructure engineers, mostly anyway. Now, it's mostly in the hands of the one who builds the container, which is kind of a challenge. Right. Let me see. Yep, the next. Sorry. Yep, there we go. So what we've learned through the years. A deployment is not a release. That's an important one. Because if you let that go, that connection, great things will happen to you and your team. More automation is more reliability is more better. Start small and iterate fast. And this is a big one. Own your pipeline and your cloud environment. Observability obviously matters. And smaller, faster, safer changes are good in comparison to large and cumbersome releases. This is pretty much my talk. So I've got a few minutes left, I think, for questions. There you go, that's good. Are there any questions from the audience? Squeak.
Keep it close to you. All right. Thank you for your talk. I was wondering one thing. You mentioned that security becomes now a responsibility of the person who creates the function. In my team, we are working with containers, and a lot of people are like, yeah, fine, I'm just writing code. And it becomes part of a container, sure. I have the challenge, how do I teach people the security of containers if they are not interested in containers?
Wow. That's a question I could skip. No, it's a good question. It's fair because ultimately, if you look at history, I think software developers were obviously already responsible for security of their own code. But now that they're packaging their code into containers, they're also responsible for the security of their OS that they're packing into their container, and all of the dependencies that go along with it. If you want to figure out how to get people to understand that, I think might be an interesting idea to come up with a container that is compromisable. I have a few. Just they have all the versions of software running, and show them how easy it is to compromise those. Because that hopefully will set in reality that if they don't update their containers in time, that means that there's a security risk in their production environment.
Sounds like a good idea. Thanks.
And come to this room at 4:10 and you will learn more about it.
And come to this room at 4:10, I just heard, and you will learn more about it. Excellent. Any other questions? All the way on top. Okay, it was a joke. Yeah. Yes.
So we went through like a story of history from the 90s and 2000s all the way up until now. But what do you see coming for the near future?
What I see coming for the near future, that's the question. What I see happening is that people are going into AI for deployments, and honestly, I'm not sure if I follow. If I'm being honest, I do see it happening that people are trying to release through AI. I don't get it that much. But it is a trend that is going on. What I think that will happen is that we'll be seeing more and more and more platforms that are going to help you as a developer to deploy your software in a safe, scalable, and secure way, so that you don't have to worry about things like that anymore. I hope that that's where the future is going anyway.
Cool, let's see.
Indeed, let's see.
Hi.
Hi.
So I'm an old person.
Yes.
That's a good start.
No argument.
I'm from the age where development was separate from ops, and I am old enough to have a hard time getting grips on the ops part.
Okay.
Now, as a developer, you say more automation is more better. As a developer, I can automate the tests for my code. Mm-hmm. Is there something similar for the ops part? Is there a way to be able to test the container before I put it into production?
Is there a way to test the container before you put it into production?
Yes.
Yeah, well, I think the answer would be what he just asked, which is CI/CD, obviously.
Yes, continuous integration, continuous debugging. Right?
I think that's what it stands for. Yeah, I have to look it up, honestly. Yeah. I was asking because I forgot, but yeah, I think that's pretty much it. Yeah, no, but seriously, obviously, the thing that you want is you want to develop locally, deploy or commit. Sorry, make sure that same Docker container goes to testing, ensure that it works fully, and then promote it into a staging or production environment.
Okay.
Any other questions?
It's time for lunch.
It's time for lunch. I've got one small thing. This is we're a sponsor. Tilla is, and we built a platform. It's called Nexa. And this platform is obviously that platform that we were just talking about, because I do see the opportunity to have a platform that everyone can use to focus on their software, deploy their applications within minutes, and no longer worry about any infrastructure aspect anymore. Like it says, no servers, no stress. It's a no-brainer. We have a booth. Come by if you want to see it in action. You're more than welcome. Thank you.